So I'm going to be doing live coding, and it will be in Eclipse collections. And thank you, Mary, and thank you, Anita. There's a terrific talk, Anita, and thank you, Mary, for the introductions. So the code kata we're going to do today, it's actually Eclipse collections kata. And can you see my screen okay?
Yes.
Mary? Everything's fine? Okay. Okay, good. So in the Eclipse collections kata, we have a fairly simple domain that we're going to be working with. We have people, so a class of person that each person can have one or more pets. And a pet has exactly one pet type. And you can see we've got different types of pets here: cats, dogs, hamsters, turtles, birds, snakes. And the way the kata that I'll be coding in is structured. It's basically a set of unit tests that, at least in exercise 1, all the unit tests fail. And our job is to get them to pass using Eclipse collections. So I'll be coding using the Eclipse collections API. In this particular test, I'll be using the collect and select APIs. So what we can first see, as we should do, is make sure like all of our tests are failing. And then we can go get to work. So the first thing we want to do is, for the first test, we want to get the first names of all the people. Now each test has access to a collection of people. This .people gives us a mutable list. What we want to do is transform the collection of a person to a collection of their first names. So we'll do this .people.collect get first name. You can see the code compiles, and if I run all the tests again, what we should see is now get first names of all people passes. Next test that we want to get to pass is get the names of Mary Smith's pets. So you can see we've got a person named Mary Smith. We get the pets off of Mary Smith, and what we want to do is query the pets to transform and collect up their names. So in this case, we're going to use a method reference and do collect pet get name. I could be using lambdas as well, but I have a method reference preference, so I'm going to use method references. Click the button. Oh, there we go, sorry. It's running, and now you can see the first two tests are passing. So the next test we've got to get to pass says we want to get the people with cats. So we've got to replace the null, query this .people, and what we want to use an API available in Eclipse collections called select, which filters on a positive condition. So we want to select a person, and we'll use a lambda here, where the person has a pet type cat. And we can run the tests again. And voila, we get all three to pass. And then the last test we want to get to pass is getting the people without pets. So one thing we can do is, let's say, just copy the code here. And I could simply put exclamation point there and negate the condition, but Eclipse Collections actually has a symmetric API where the opposite of select is reject. So this will reject any folks that have this condition. So this will give everybody that doesn't have cats. So if we run the tests, we can see they all pass. And yay, we finished exercise 1. And now what we can do is I'm going to finish up exercise 2. And you'll see, like, in the links that I sent, we're going to be coding exercise 1 and 4 of the kata. And you can see links to the kata as well as solutions I've provided online. And you can take the kata on your own if you want to explore what I'm doing. Now, I've taken this kata probably 100 times and taught it. So I'm going to do exercise 4 now. And in exercise 4, there's a whole bunch of APIs that are used. And the purpose of exercise 4 is to show how you can move from streams-based code to using Eclipse collections. And this is a refactoring activity. And what you see is all of the tests pass in exercise 4. What we want to do is actually replace the streams code with Eclipse collections code. And if you look at what's going on here, we want to get the age statistics of pets, right? So each pet has an age, and we want to collect up a list of all the ages, also then get a set of them. So in this case, we'll replace the streams code, and I'll just leave it there so you can look as I'm typing. I want to flat collect, which is equivalent to flat map, all of the pets from the people. And then I want to actually collect int, which is the equivalent of map to int, the age of each pet. And what this is going to give me, I'm using var here. And if I hit Alt-Enter, if I want to see what the type is, I can replace the type, and you'll see that this is a mutable int list, right? I can switch back to using var. Now with the using the mutable int list, you can see I can no longer create a hash set out of that. But what I can do is, if I want a unique set of ages from that list of ages, I can just say petages.toSet. I no longer can call .stream on pet ages because it's a mutable int list, but I don't need to do that. I can actually just go petages.SummaryStatistics to get the summary statistics. And if I look, this will be the JDK type of int summary statistics. I no longer have an object-based set. I have a primitive set now. So what I want to use here is an call to int sets to create a set. And this is a class in Eclipse collections. And the rest of the assertions are basically doing things like min, max, and average on the collections. And what I can do is I don't have to do .stream and do map to int each time. Petages actually has the methods directly. We don't have to, it doesn't return an optional. Instead, what you can do is call min if empty, which will specify default value in case it's empty. You do the same thing for max if empty. Sum is just sum, it'll be 0 if it's empty. But average, we need to check the empty condition as well. So we'll do average if empty. I can drop the or else. And pet ages, so in Eclipse collections, the equivalent of any match, all match, none match on streams. The names are any, all, and none, but it ends in satisfy. So all I have to do is replace this with satisfy. And now I can get rid of all of the streams code. A bit simpler. I should be able to run the tests, and hopefully this one passes. Oh, they all still pass. Okay, good. I haven't broken anything. That's a good refactor. All right. The next method we want to change is code that's finding the first person that matches the name Bob Smith. In Eclipse collections, I would use a method called detect. Detect will return null if it's not found, which is the equivalent of calling an optional.get. So I can just replace it with that. From the names, instead of calling map, if I was using the Eclipse collections API, the method is called collect. And I will call collect pet get name. There's a method on all the Eclipse collections types, which effectively is the same as doing like collect collectors joining, which is called make string. So I can just call that, get rid of the extra parenthesis. And I should be able to run all the tests, and they should all still pass. And they do. Next thing I want to do in this particular test, what we've got is we are counting up the pets by their pet type. So we want to, in the JDK case, we're actually getting a map of pet type to long. I'll convert that to var. I'm going to rename this to just counts. And if we want it to be unmodifiable, I'll make it unmodifiable at the end, you'll see. So what I want to do is, instead of this .stream flat map, I'll just replace this with flat collect. It's going, flat collect works with iterable. It doesn't work with stream. It doesn't require streams. So then I can convert this to a method reference. The next thing I want to do is, instead of calling collect collectors grouping by pet type collectors counting, this can all just be replaced with count by. And I can drop the counting at the end. Oh, I don't need unmodifiable map anymore. What I want to do, though, is if I want it to be unmodifiable, I can just call one extra method as unmodifiable. And if you look at the type here, if I want to expand it out, this is going to be a different type. It's a mutable bag of pet type. Now, bag is a type that you don't find in JDK, but I'll convert this back to var. Now, with a mutable bag, I don't have a method called get on it anymore. I instead have a method called occurrences of, and the return type of that is an int, so I don't actually have to box up long values to see what's in a map. So these just become int values here. And my test should all still pass. And then the final method that we want to refactor, a bit more involved, but it's going to go fairly quickly. So what's happening here is we're getting a count of the pets by pet type, but what we want is we want to know what the top 3 pets are. So what we can do is we'll just rename this to favorites. And I'll get rid of the dot stream because we have the methods directly on the collections. I can say flat collect. I don't need the dot stream anymore. Once this lambda exists, I convert that to a method reference. We don't need to do all this. We can just make this count by. Now a bag has a special method on it called, which is useful, called top occurrences. And we can just say top occurrences 3, which we then get rid of all of this. Now, if you want to see what the type of this is, we'll expand out the var, and you'll see that this is a mutable list of object int pair, which means this isn't going to work with a comparison, and the test should actually fail just to prove it. I can't compare it to simple entry. I've got to compare it to something else. Yes, it fails. And what we want to do is convert each one of these to another type, which is an object int pair, and we can get that by calling primitive tuples pair, and it'll be pet type of mapped with an int. So we just want to convert these to int, and I'll do the same here. And we should be able to run all the tests now, and hopefully they'll pass. Okay. So now we have successfully finished the 2 exercises in Eclipse Collections Kata. So exercise 1 and 4. And that's all I have for the talk. That's hopefully within 10 minutes. I can actually take questions if folks want. Plus, there's the links in the blog that I published, which you have in the chat. And the Eclipse Collections Kata is up in GitHub. There's 3 different katas. There's a blog I wrote a while ago called The Tale of 2 Katas. It explains how to check out the kata and actually accomplish it. I also wrote a article in the JVM calendar, I think a year and a half ago, JVM Advent calendar, and it got published on VZone, which basically, in this blog, I solve exercise 1 several different ways. I use streams, I use Eclipse collections, I use anonymous interclasses, I use lambdas, I use method references, so on and so forth. So all these are available as links. And with that, I would say, thank you. Once again, if there's any interest, I could take questions if we have time, or we can pass on the baton. The next speaker.
That's really great. Thank you. Does anybody have questions for Don? You can unmute yourself and ask directly.
What is a kata?
Great question. So kata, similar to I guess in martial arts, a kata is a structured exercise that you can learn different martial arts skills with. And in programming, similarly, a kata is an exercise that you can use to practice and hone your programming skills. So what you just saw me do is I've taken this kata 100 times and taught it. And what you can see is I can work very quickly through it because I've worked through and kind of learned the motions of how to solve different problems using this different APIs, right? So similarly, I usually use the example in martial arts. I don't do martial arts myself, but I've seen The Karate Kid quite a few times. And if you've seen The Karate Kid, when Mr. Miyagi is getting Daniel-san to paint the fence and sand the floor and wax the car, these are all katas. And what Daniel-san is doing, he's actually learning defensive moves like this, right? Or so they're different, defensive blocking moves. He doesn't actually know he's learning karate, but that's effectively what he's doing. And he's meant to basically get to the point where the moves become so fluid for him when, he sees someone attack him, he can just move his hand quickly to defend himself. And similarly, you see a problem in a kata, and the more you practice it, the more you can, get your coding expertise to a point where you can quickly solve a problem, knowing exactly what you're looking for. So it's really once again, building up your skills through practice. So And that there's a lot of description of this in the various blogs I've linked to and whatnot, and in the Eclipse Collections kata itself, which let me open it. So if you go to the kata in GitHub, you can see there's the description of what kata is, right? So exercise and programming yourself to your skills through practice. Now, as it turns out, one of the things I didn't mention, and I also didn't mention, so some of the things, I'm a Java champion as well as the Eclipse Collections creator, but I'm also one of the contributing authors to 97 Things Every Java Programmer Should Know. And you can actually read my contribution. It's actually up on my blog. And you'll never guess what it's called. It's called Learn to Kata and Kata to Learn. So this is actually an article that I wrote that will teach you how to build your own katas. And then you can share them with yourself and, to practice things that you want to get good at or to share with others, right? So that was the whole, article that I wrote that, then got included in the published book. And I've got, hey, here's my copy. It just came in the mail like last week. So thank you for the question.
Thank you. I learned something new today.
You're welcome.
Of the Karate Kid, so.
Yeah, it's okay. I find that one works pretty well because a lot of folks, I don't practice martial arts. I think folks that do will understand right away what a kata is, but I think a lot of folks have seen Karate Kid, so.
Thank you.
Well, I'll stop sharing. You're welcome. Thank you. Now I'm going to do an unprepped. Yeah. So, what I'll do is I'm refactoring in reverse now, right? So I'll start from the Eclipse Collections APIs and switch back. And what I'll do is since the Eclipse Collections katas, if you check them out, they're all in. We upgraded them to Java 11. So as you saw, I was using var everywhere. But to convert this to streams, to go in the reverse direction, what I would do is to get the first names of all people, instead of this.people collect, this becomes this.people.stream.map. So I replace the collect. But since I want to compare it to a list, this would actually fail right now because the stream and a list aren't equal, right? Oh. Although the compiler is not telling us that, right? Because we're just doing an equals comparison. So what I got to do is then call collect and do collectors.toList. And then this will pass.
I actually haven't used Eclipse. I should really look into this. Yeah. So.
After watching me tonight, hopefully you check out the kata.
Yeah. Yes.
But,
yeah. So good.
Yeah. So doing the same thing for this one, you just do .stream. Collect becomes map. And the names for Eclipse Collections, there's a blog I wrote called Java Streams Are Great, but Java needs I guess new collections. And it kind of explains where the names. So the names I use in Eclipse Collections are actually from Smalltalk. So I was a Smalltalk developer.
Oh, I see.
Back in the 1990s. And once you're a Smalltalk developer, it's hard to break that habit. Oh. So you can see the type isn't compatible here. It needs to just be a regular list. So either I could change this to list, or I can replace it with var. And make string won't work anymore. So what I want to do is I would just use, let's say, string .join. Do common names. Now hopefully this passes. Yeah. This is, it's something I've done throughout, the past few years as well. I was actually on the JSR 335 expert group with Brian Getz and Josh Block and Doug Lee. So, I was there as we were working on, lambdas and the streams API. So I had to learn a lot about streams. So I've become very fluent in both. Yeah. For select, it's filter. So this would be, instead of select, this becomes filter. I now have a lot of method calls there, so I'm just going to stack them up. And we want to get it into a list, so I'll do collectors. Now, one option I actually have is Eclipse Collections itself actually has its own collectors. So if I did collectors 2, this would actually give you back a mutable list, and that would work.
Oh,
But if I want to use like standard collectors that are in the JDK, I can convert this, let's say, to var. I can make this just regular collectors,
oh.
and then it should still work. And for this one, if I convert it to var, and now there is no opposite of filter in streams. So what I have to do for this one is I'd have to do that stream. This becomes filter. And now what I have to do is I have to put the not in here.
Oh, you can do like not. Okay.
And now this should pass.
Without caps, yeah. Now I see it.
Yeah, so and they should all pass. And I'll show you one final thing, and it's kind of a neat feature in Eclipse collections. So I mentioned when I was coding before, I love method references, right? They're like nice and succinct, and they're self-documenting. I don't have to come up with a good name, right? Because if I converted this to a lambda, the downside is that sometimes what folks will do is just give this a meaningless name.
Oh, yes, that's right. Yeah.
So I have no information about what this thing is now, right? Whereas when it's a method reference, it includes the class name, so I can see the type.
Yeah.
Right. I know that that's a person, right? I don't need the duplicate, variable reference. So I tend to like them because they're more concise, but they're also self-documenting.
Yeah.
But what's interesting is when I did this solution before, if we go back to Eclipse collections, then I just make this select, and then I don't need the extra collect call. I can actually use a method reference here, but the problem is I need to actually pass this in as a parameter. And it turns out there's more APIs in Eclipse collections. There's a method called select with, and what I can do here is I can say give it the person has pet as a method reference, and then pass the second parameter onto the method. So select with actually takes 2 parameters. It takes a predicate too, not just a predicate. So it'll then take this second parameter and pass it in, and this actually matches successfully to the this method. So this method is on person. So the first parameter of the predicate is going to be person. The second parameter is the pet type, which is what I'm passing in. So this actually works. So I can actually use the method reference now.
Oh, okay. Oh, it's okay. I see.
And so I can then do the same thing here. So instead of all this code, I can just take this and change this to reject with. And then that will work. And I in the one of the articles I linked to in the blog, I give examples of this. So let's see in my blog for tonight. I'll make the font bigger. So this one, the 19 lessons in Akata. So if you read this article, I do the same thing. I take exercise 1, and I just try different ways of solving the problem. You see, I solve it with a lambda.
Oh, okay.
And then I'll solve the same problem using a method reference, right? And this then allows me to use the same thing with, so I use streams with collectors 2, without collectors 2. I'll show the select with example. Because there's a lot of different ways to solve these problems, right? I even go back and show like older versions of Eclipse collections. The framework's actually compatible all the way back to Java 5. So Eclipse collection 7 will work with like JDK 5 through 8. Eclipse collections 8 and beyond is compatible with 8 forward. But you can actually, in any version, you can still use anonymous inner classes, and I show how to do that as well. I imagine eventually folks will forget how to do anonymous inner classes because now that we have lambdas for the last 6 years. Yeah, so I call this like 19 different ways of solving these exercises. So
yeah, true. But how do they compare, right? Is there any like performance type of thing that we need to be aware of, between the different ways of using them, right? Like what are
So I actually have one of my blogs. There's a bunch of different things. There's performance potentially, right? Now, this is an eager method directly on the collections itself, right? So what you can do is you can step into the code for select with and see what it does. We're going to see a lot of implementations here. Hopefully I checked out the code. Let's look at fast list. And at some stage, what you're going to see is there's going to be a for loop. And there's the for loop.
Okay, yeah.
So I wrote a blog a month or two ago, I think, which explains the difference between it's called eager is easy, lazy is labyrinthine.
Oh.
And what this blog tries to do is explain the difference between, and actually, I wound up implementing a collections framework from scratch. It took me about 4 hours. And what I wanted to do is basically have something similar to what we have in Eclipse collections, but using all of the streams protocols. So what you see is like, I created all of these interfaces and I actually implemented it all. So you can see methods like filter map, but I implemented them all via eager APIs. And in this blog, I explain the difference between an eager API or an eager iteration API as well as eager initialization. Eager initialization, most folks have seen, right? Either like initialize a list as soon as you need it, or in the case of, I want to lazy initialize, let's say, a list, right? So I don't create it here, I do it in the method call, right? And you can see this is slightly more complex, right? When you talk about lazy iteration, what I do is in this blog, I compare this code here is, let's say, the eager approach where the method is directly on the collection. And then I show exactly the same API name implemented on streams, which is going to be lazy, right? And then what I do is I show what it's like to actually debug this, right? And you know what? We can actually do this. Let's test it, and we'll debug it. I love live coding. Let's make this work.
Wow.
So we'll go back to my test. I love doing everything in unit test.
Yeah.
I just got to import some stuff, so let's import. Except for I won't be able to do that. I don't have, let me think. Give me a second. I'm going to open another project. Got us, good, got us. There we go. I think I probably have the tests already in here. Okay, I think there we go. Hopefully I have Java 14 installed. Oops, wrong one. Yeah, we should be good. Let me just make sure I can run the test. Okay, so what I do in the blog, which if you go through and read it, I'm showing what happens if you stick a breakpoint here. And I want a breakpoint on the lambda. So what I want to see is, when do I actually see this executing? And if we debug through this, what you'll see is like you get a stack trace here, and this is probably kind of tiny on your screens, but I see like this is the filter method in the test, that method that we're in. This is the filter method on the collection itself where I've got the eager implementation. And if you look at the code, you can kind of walk through it and read it and understand it. So filter takes a predicate. It creates an empty list. It then iterates over itself. So it's got a for loop on itself. It tests a predicate. If it returns true, it's going to add the element to a collection. So this is fairly easy, I think, to actually read. And this is the eager implementation. And you can step through if you want. you know, then see what's happening. So if I run to the next one, so you can see I'm on each is 1. So it's a list of 1 through 5, right? And you can actually see this is the list 1 through 5. Well, it's index 0 through 4, but elements 1 through 5. And if I keep, I wanna, where is it? Okay, so if I step over, right, you see I'm going to go there, and then I'm going to hit there. Now what is each? Each is now 2, right? So you can see I'm in the loop. And it's just going one by one, right? And you can see the iteration, right? So it's easy, once again, easy enough to read. And as a developer, to show you what this looks like outside of the debugger, if you were to step into the code from the test, so here I was debugging, right? What happens when you step into the code? I see that method I was just debugging through, and I can read this code. I create an empty list, I have a for loop with a if statement that checks some condition and adds to the list if it's done. So this is what the filter, this is a filter algorithm eagerly implemented. Now, if we try and do the same thing lazily, we're going to have a different experience. So I put the breakpoint on filter, right? And now when I debug this, let me make sure I'm not debugging. I stopped. Okay, good. So now if you look at the breakpoint, remember before there was like 4 methods in the stack? Now there's like 10, right? So I look at the filter method, you can see I stopped there, right? But what you'll notice is I'm not in the filter method. I'm in the collect method.
Oh.
Because filter is lazy. Filter doesn't do anything.
Oh, okay.
Filter gives you back a stream. It's the collect method that's a terminal operation that then forces execution to happen. So when I'm in the breakpoint for the Lambda, even though it looked like I should have been in filter, I'm not. I'm in collect. Right?
Yeah.
And now when you look at collect,
We lost you, Don. See if I can.
Yeah, we can see his screen.
look at that.
Yeah. Oh, we lost you for a few seconds.
Oh, am I back?
Yeah, you're back.
Okay. I was just saying, like, if you look for the for loop somewhere in the stack, you'll see a method called for each remaining. That's where the looping's going to happen. But if you look at for each remaining, I don't really see anything that would explain to me what algorithm I'm looking at. And it's much more complex, right? The behavior that's happening here. You might be able to try and figure out, well, action is a consumer. It's not a predicate anymore, right? And if you look at what action is, it's, let's see. Yeah, it's accept. I mean, it's going to be on consumer. You can't really see, once again, where the check is going to be done. You'd have to look on the accept method. And then you see here, we're in the accept method is on something called the stateless op, which is, you know, inside of it is a sync chained reference. But you see an if statement here. You might start to reason, well, and you see the element 1. But if you try to like step through this, you're going to get lost very quickly, right? So the point being, and similarly, like if I stop debugging and if I just want to step into the code from the test, right? So here, if I step into filter, you'll see it's on an interface. I don't see any implementation, so I have to step in, and there's only one implementation. And this is what filter returns. So you have to understand, I guess, what all this stuff is. But then, once again, filter doesn't actually execute. You also have to then step into collect, which it's also not an implementation. You have to step into an implementation. And here's the implementation, which is what we were stepping into before in the debugger. So what I'm trying to, I guess, explain in this blog is that if you're a developer and you see an API and you step into the code and you want to understand it, it's much easier to understand the eager implementation directly on a collection than it is to try and understand the lazy. And I'm not trying to say that lazy is bad. I'm just saying it's more complex. It's harder to understand, right? And what I'm kind of advocating for is you need both, right? It's not an either or. It's like you want both the eager implementation and the lazy. And in the blog, I explain where the benefits of lazy come in. And this is an interesting thing to reason about as well. I show if you've got a bunch of code, I don't know if I have this example in my code base, but basically in this example here, I show like a filter map reduce set of steps. And you can see I'm sticking calls to peak in between each step. So you can see what the input is to the next step, right? And then I use this to basically show the output for both eager and lazy. And what you'll see is for eager, you see we call filter, and then we call map, and then reduce. And what happens in eager is you see filter, filter 5 times, then you see map, map twice, and then reduce, reduce twice, right? With lazy, the order's different. It does filter, filter, map, reduce, and then filter, filter, map, reduce, and then filter, right? Now the result is the same, but the order is completely different because what's happening is like the way a stream works is it's going to pass something all the way through the pipeline, right? When it hits a condition to flow through. Now this is beneficial. You don't see really a difference here. And in this case, I would suggest you'd have to measure it, but in the simple case where you've got a single method call, I believe there's going to be more overhead and more cost to you than on a lazy implementation than on an eager. It may not be interesting or measurable, so I wouldn't say like base it on performance, right? I would say like have less method calls and have something that's easier to understand. But where you get the benefit for lazy is if, in this example, I use a short circuiting method like any match. So any match, as soon as it finds a condition that matches, it'll short circuit. That's kind of what its purpose is. But if I've got a stack of collection pipelines, so here I do filter, map, and then any match, right? In the eager case, I've got to filter everything and then map everything, and then it'll stop when it hits 2, right?
Okay. Yeah.
And here I've got a list 1 through 5, so it should stop here, but I've already filtered everything. I've already transformed the 2 that are left, and then I'm going to actually test. What happens with lazy is you only filter up to 2, you map that right away, and you see, oh, we've got 2, we're done.
Oh.
You see, it does less work.
Interesting.
Yeah.
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 Yeah. So I think this is something that, I think a lot of folks internalize how, lazy works and that it does work, but like, I think a simple visualization of this is useful to understand, once again, the difference, right? So you can see with eager, there's another problem as well, potentially, is if you've got multiple steps, you're going to create lots of temporary collections in between. So I filter into a collection, I map into a collection, and then I'm, returning a Boolean value. Here, there's no intermediate collections on the lazy implementation. So if you've got a stack of operations, lazy is typically going to be more efficient. I have a whole blog on that explaining when to use. That one's actually called, let's see. It's one of my favorite blogs. It's called the 4 a.m. Jamestown Scotland Ferry and Other Optimization Strategies. This is a much lower blog. I explain eager and lazy similarly. I'm comparing the Eclipse collections to streams, but we also have a lazy implementation with Eclipse collections. And the lazy implementation of Eclipse collections, our lazy implementation returns an iterable, which means you can reuse it over and over again. When you use the stream from the JDK, once you've used it, it gets exhausted, and you have to create another stream. You don't have to do that with our lazy implementation. But what I show is the same kind of thing, the order of execution, which is different. So filtering, mapping, and I do it with Eclipse collections with streams. But then what I do, and this is probably what you're looking for, Mary, I do performance benchmarks on it.
Oh, okay, great. Yeah.
So, and I show the difference between object collections, primitive collections, doing it in serial and in parallel. Across streams, we have a parallel implementation. So I'm comparing all of them. And all the code's here if you want to try it on your own. Don't take my word for it. So I include all the benchmark code here.
Oh,
You
wow.
can see what the code looks like.
That's amazing. Wow, thank
So,
you.
and I figure like this is a useful thing to capture if people want to like dig in and really learn. And Eclipse Collections, it's been in development for 16 years, right? And it's about if you compare it like because we have primitive collections and Eclipse Collections as well as object collections, hand coded there's about 400,000 lines of code. With code generation, it winds up being over 1 million.
Wow.
And in comparison, like, and I'm not saying that lots of code means a good thing by any stretch, but like in comparison, like if you look at streams, it's about 15,000 lines of code. So you're getting a lot of functionality in streams. It's not as, let's say, complete as what we have in Eclipse Collections, but you can see there's a cost to that completeness,
Sure.
which is a lot of work. Now that you get benefits with the cost, you can see like for different operations, and this is the more interesting one. Like you can see I'm showing simple operations like map, sum, reduce, and then I show a combination. Well, you filter, you map, and you sum. And you can see this is where stream starts to actually show some benefit because I'm stacking multiple operations. And at the end, I kind of recommended, these are my recommendations.
Oh, nice.
I prefer primitives over boxing.
Yeah.
I prefer eager iteration for single or fused operations. I prefer lazy for multi-step. You really need to measure and benchmark before you try and use parallel. You're just going to
Wonderful.
keep your servers warm. And if you want a lot of choice, you've got Eclipse Collections as an option. So,
well,
thank you for attending my TED Talk.
Oh, I love it. Yeah, I'm so glad. Yeah, like nice bonus for.
It's funny because that's how when I started out. Yeah, I'm a babbling brook, right? I can talk for hours. So the fact that I could do it in 10 minutes is a stretch for me.
Oh, I love it.
You do it well.
Yeah, great. Thank you so much, Don. Really appreciate. We have to book you for in person when when we can travel again. I have to have you. Yeah,
I'd love to. I haven't been. It's funny because I haven't been to Chicago since like 1990.
Oh, then you need to come. Yeah,
Yeah, I love that. I loved Chicago when I was there. So
yeah, we love
it'll
it.
be fun.
Yeah, oh, yeah, great. Yeah, awesome. Thank you so much.